Okay, so let me start. uh, Today we will revise a little bit from the last time, like if you have missed the last session. So I'm just going to share my screen. Yeah, let me know once you guys are able to see. You are able to see, right?
Yes, Anupam.
Okay,
Yes, Anupam.
sure, that's great. So last time I talked about little bit history about the cloud evolution and why Snowflake has emerged as a cloud data warehouse. So in past, like we have very less data, and also the computing power and storage power we have very less. But as you see, the evolution of technologies, it's coming, and uh, like you have more compute power and storage available in the cheap rates. So that's why like the cloud entire thing runs on the commodity hardware. Like they are like as compare, if anyone one particular person will own it, it will cost a lot. But as they are owning it and they are sharing with the other customers, so it costs us a very small part of that. Okay, so that is why like cloud is just a pay per use, or as per the usage of your resources and the storage. So that's why like in 2020 we see like the AI and virtual reality and RPA, they are on the boom, and we have lot of data coming in, means starting from 2015 when we have the social media and all. Okay, so why Snowflake, or like I can say what is Snowflake first. So Snowflake is basically a cloud data warehouse which is built from the scratch for the cloud only. One thing to note here, the Snowflake is OLAP. Okay, it's online this analytical processing. So we cannot have that transaction capability in this Snowflake, but it is mainly used for the data storage for the long time, and as the name suggests, Snowflake data warehouse. So it is for our mainly for the analytical purpose only. Okay, so then we have seen some of the features of it, like it's new in industry and built for the cloud. Cloning and time travel, these are the two features, and it is like compatible with the SQL queries which you can write for any of the relational database. And also it is providing the JDBC connectors, and also it has integration with multiple tools. So it has direct connections with Informatica, Matillion, Penthouse, Streamset, and so many. And if you want to use it in any programming language, then you can use the JDBC connector as well. Okay, and we just need to pay for as much we use the Snowflake, and otherwise it won't charge us anything. Okay, apart from this, in Snowflake you have the single place of data. That means entire data from different applications, different types of data, means it's a structure or semi structured, and you can store multi petabyte of data as well there. Okay, the second thing is scale and concurrency. So you can scale your warehouse. I will explain in the next, like what is warehouse and all. So we have the computing power, we can scale it, and we can have more concurrency as compared to the other traditional databases. Zero management means there is no indexing required, no table space management is required. So very less this sysdb activities are required in the Snowflake. Okay, then the instant live and data sharing. So to access the Snowflake, you just need to create your account, and you can use Snowflake in within 2 minutes. Okay, whereas compared to other databases, the typical on-prem one, the Oracle and others, right? So they need installation, user creation, and so many things, right? And on the Snowflake you can also do the data sharing with any of with anyone, like who has even who has or who does not have the Snowflake account as well. Okay, so you can create and share your data set with them. Okay, last time we discussed how we can use the Snowflake. So you just need to go to snowflake.com, and there you can create your account. I hope like who has joined last time, they have created their account and they are able to see like how it look and feel for the Snowflake. Okay. So yeah, any question?
Yeah, Anupam, just quick question. So I missed the last class. So
Okay.
I just want a quick understanding of how Snowflake is different from AWS Redshift or Google BigQuery data warehouse, right? So how it is differentiating from these
Okay.
the public cloud providers?
Right, right. So, as I mentioned, like it is different from the on-premises one, but as you name it, right, the Google BigQuery and Amazon Redshift, right? So they are also on the same line, right? They are also in the cloud, and they also provide the scalability and all, right? But
Yes.
I use Google Query. There, I have not seen any option to increase the warehouse sizes. Means the compute power I have not seen. We can configure it like I haven't seen in the BigQuery. Okay, I know like the BigQuery automatics it choose the compute power and all, because in BigQuery the charges are based on the query execution and the data scaling, correct? So they have the per query you need to pay some amount to them, right? But here in Snowflake we have the power to choose our execution engine, like how much big size for our need if we require, or how small size of warehouse we can use it. Okay. Redshift I haven't used, but it is also on the Amazon, right? And it is also on the cloud. But um, like as compared to Google BigQuery only I am aware, but not about Redshift. Okay.
Okay.
Yeah. Have you used the Redshift?
No, I haven't used Redshift also. So just BigQuery I used not deeply,
Hmm.
but just on a high level I used. So
Okay.
just want to understand, but how Snowflake will serve as an alternative for those. I mean, these two cloud data. I just
Okay.
want to understand that. Hello.
Okay, okay. Like they are on the same category, right? They are cloud data warehouse, and they provide functionalities almost the similar, right? But here and there they have some unique features as well. But like as I mentioned, like I have not used Redshift, so I cannot comment on it. But BigQuery I have used, and there we can just means they charge based on the data scanned and the number of queries we executed. But in Snowflake,
Okay,
like
but
yeah, in Snowflake the architecture is like the compute power is different and the storage is different. So it charge for the data where it is only stored. Okay, suppose you have like 10 GB of data, so it will charge you only for the 10 GB of storage only. Okay. And compute power is like for how much time your warehouse was up and running, for that time it will going to charge you. It is not like based on the queries, it is like based on the time. So
yeah, okay, got it.
yeah, so when we create the account, right? So let me share it again. Let me open and share it again. So yeah, so yeah, let me know once you're able to see. So once you go to snowflake.com, you will see this screen, and you should go to start for free. Okay, there you can choose means you can fill the basic information. I'm just filling just to show you the next page. So here you need to choose the warehouse. Oh, sorry, the cloud first is the version of it, or the edition of the Snowflake: standard edition, enterprise edition, and the business critical. Hmm. The difference between standard and enterprise is the 90 days time travel. This is available in the enterprise. So what is time travel, I will explain later. Multi-cluster warehouse and materialized view. So we are going to see multi-cluster warehouse today, And this materialized view also, it is only supported in the enterprise, it is not available in the standard version. Okay. In the business critical, like whatever the features of standard and enterprise, those are there. Along with this, we have more enhanced security, data protection, and database failover and rollback. So those are the more some more feature available, which is like very critical for the business. And we need to choose for with which cloud provider you can go for the Snowflake creation. So basically, Snowflake itself does not have any cloud platform. It uses the other public cloud platforms for its storage as well as for the compute. So we have Microsoft Azure, we have available as this Amazon Web Service, AWS, and the GCP. Okay, so the reason first is like the reason to choose the which this cloud provider, it depends on your enterprise, right? So suppose they are already using AWS, so it is better idea to go with AWS only to manage the accounts and all on the single console and all, right? So that is one thing. Other thing is the availability region, right? AWS will have most of the this yeah most of the this region available. So we have some of the compliance, right, where you need to store your data. So in some of the countries they have the regulations like for the country you should have your servers in country premises only. So in that case, for that reason, like you should choose whichever is suitable for your that requirement, the compliance need. Okay, so you can see like if I go with this now, we have Asia Pacific as a Mumbai. So suppose someone say like we should store the data in India only, so it is available in AWS, but can we check in this? So yeah, in Azure we have in Pune, and in Google, yeah, so Google is not available. The reason is like Google is recently added with Snowflake. Previously the first cloud provider which was with Snowflake is AWS. So that's why you can see most of the this availability zone and regions are available on AWS, whereas in Azure we have almost similar, I think, and in GCP we have only 3 regions available as of now to choose. So it depends like which. And the third thing is the latency. So for your from your places, which is the nearest the cloud provider location, if you choose that, then you will have less data latency. Okay, so these are the options you should keep in mind to choose your reason and all. Yeah, let me come back again to the our presentation. And there is like now we are going to discuss about the architecture. So what is Snowflake? That point is clear, right? So first thing, if you compare from the traditional data warehouses, right, we were using mostly Oracle or Teradata as a on premises, right? And for those to have those Oracle or Teradata or any other, we need to first buy the hardware or the licenses from the provider, and that cost a lot of upfront fees. Okay, they charge a lot upfront. So with the help of cloud, right, we can get the compute power and the storage power like in within seconds or within minutes, and with minimal expense upfront. So that is the main feature of cloud. So if your company is pushing for the cloud, right, so that is the main feature, because it is having very less as a expenditure cost. It has mainly the operational cost it associated with. So that is the one of the main feature. Okay, second thing, if you think of Oracle, right, so suppose number of users are running on the Oracle. So if 50-60 users are running simultaneously, the performance will degrade, whereas in Snowflake there will not be any performance degrade. Okay, so that is why to use a better architecture or the better platform, we are going with the Snowflake. So Along with Snowflake, we have Redshift as well as Google BigQuery. They are also on the same line as a cloud data warehouse, but they have means own product have its own features, all benefits, but as I have not used most of them, like the Redshift, I have used only BigQuery, so I know about it, and the billings and all are different from with each platform. Okay, so now come to the Snowflake architecture. In Snowflake, we have first the storage layer. Okay, so in Snowflake, we have separate storage layer and separate compute layer. Okay, whereas in the traditional data warehouses, suppose Oracle, right, it is tightly coupled, the compute and the storage. Whenever you need Oracle servers, they come with a combined, the storage and the compute power tightly coupled in a single server, whereas in Snowflake the storage is separate and the compute power is different. So the first layer is the storage layer. On top of it we have the compute layer, and you can see there are like chunks of compute power. That means there are multi cluster we can enable on the top of the storage to query our data, or as per the different business units we can create the warehouses. Okay, I will explain like what is warehouse. So the compute power is called as a warehouse or virtual warehouse in Snowflake. On top of that we have cloud services layer. So this is mainly the services layer or the brain of the Snowflake, where these things are happening: the optimization, management, transactions, security and governance, metadata, and sharing and collaboration. So underneath we have only just compute, simply compute. So we are just giving the command to the compute, it is just computing. That means it is going to the database, fetching the data, and giving it back to the cloud services layer. Okay, if we think of AWS here, this storage power is S3 bucket. In GCP it is the cloud storage. In Azure it is I think blob storage. In compute for AWS it is EC2 machines. So basically there are a lot of EC2 machine we can configure to execute to improve the power of our query execution. So underlying it will be the EC2 machines, and how they are working to get the data, that is coded or designed in the cloud services layer. So you need to get more information on this layer. Okay, and the compute layer. So storage is simple, it is like just S3. So if you are aware of any cloud storage, it is the same, where you have like the data redundancy, the replica factors, and also everything is there. And if we talk about the cloud storage, they are kind of virtually infinite. So there is no need to worry about the storage in your database. You can store any amount of data in that, like petabyte of data as well. Okay. Okay, so we were discussing these warehouse sizes. So let me show you the our Snowflake screen, and then we will go deep into the warehouses and all. Okay, all right. So any question till now? Like it's good, it's understandable, or you need some more explanation on the topics we discussed?
No, Anupam. So here in Azure, what will be the compute like?
Compute is that I think virtual machine, we called it as a virtual machine, I think.
Okay,
So wherever you can create the server, right, on the Azure. So I'm pretty sure on the AWS it is like EC2. The services is called EC2, Elastic Compute something. In Azure it is I think the virtual machine, and on GCP also it is on the same line, virtual machines, I think so.
okay.
So are you familiar with the Azure?
Yes, Anupam. So in our project we have everything on Azure,
Mm-hmm.
like the Snowflake we have on Azure, but we didn't interfere with the Azure services. We just log in into the Snowflake and do our work.
Yeah,
So
so
at the backend we don't know
correct.
what.
So the same lies with any other cloud provider as well. Snowflake provide like the execution and all seamlessly. You no need to have any knowledge on the cloud side. Means the cloud provider side. You no need to have the knowledge on the AWS or Azure or GCP. You just come here, this is your screen, you can write your queries to fetch the data, you can create tables. So whatever the operations you were performing previously with the your in premises database, the same you can execute here without worrying about like what is happening underlying. Okay, but this is for our knowledge. And as I also don't know like how, if you are just executing any query here, how it is going to tell EC2 to run that query and bring the data. That is also not clear to anyone or not open to anyone. So it's like Snowflake its own IP. So they make it, and that is why like Snowflake is better and compatible to any of the cloud provider. Okay.
Okay, yeah.
Yeah, so no need to worry about the underlying cloud. So that is just for knowledge, and there is no prior knowledge required to know the Snowflake of any this cloud provider. Okay, so
And the
mhm,
edition you explained before,
mhm,
like standard enterprise edition. So, how much time travel we get in the standard edition?
correct. So in
Like,
standard edition, by default you will get only 1 day worth of time travel.
yeah, because in our development environment, we can only recover the data which is within 1 day
So
old.
so see,
So,
it is not like if in dev environment you are able to travel back to only 1 day. That doesn't mean you have the addition as standard only. Okay, you can have the enterprise edition, whereas you can set, or your admin has set the default configuration for your dev environment. Because see, dev environment is not like uh, any production data, right? If you delete the data or truncate the data, it can be easily reproducible, right? Whatever you have
yes.
in the dev. So that's why time travel we generally use in such a case wherever the data is like very much important, and there are certain chance, or there may be some issue with the data in last 90 days or something, right? So with the enterprise edition also you can get maximum time travel by yourself till 90 days only. Okay, after that there is a fail safe time period of I think 7 days or something, whereas Snowflake can go and retrieve the data for you. You directly won't have the access to retrieve the data after your time travel time has elapsed. After that, in enterprise edition you will have some fail safe or failover time when Snowflake can retrieve the data for you. You will not have directly access, so you need to raise ticket to retrieve the data. Otherwise you cannot do it directly by your own. Okay.
So Anupam, means a cloud provider is means required for the time travel purpose,
So
dependent on the.
this time travel feature is available for all the cloud provider.
Okay.
Okay, so time travel, let me explain the time travel only in a short. So time travel means you can go back in time and see what data was there at that point in time in that table or the schema or anything. Okay, wherever you can see the data, or it is mainly the table only, right? At that point in time what was the data is there in that table. So that is called the time travel. That means, suppose you created some table, then you updated something, then you deleted something, and again you inserted something. In a standard edition also, within 1 day if you made all these changes, you can go back in particular time, right? So suppose you want to go back 2 minutes. Okay, you can go there, you can do that. You can go 5 hours before, right? So there are certain options available within Snowflake. There you can go back in time to see what was the data at that point in time in that table. Okay, that point in time, or when you executed that query, before that what was the data. So this feature is helpful when suppose you made some mistakes, correct? You did some deployment of your production release, right? And that messed up something in your tables. So generally what we do as a best practice, whenever you are deploying anything into production, what you are doing most of the time, if you are performing any DDL or DML, you are taking one copy of that data, right? In Oracle, we generally we most of the time we take one copy of that table before migration, before deploying our DMLs. And once that DMLs are done, then we validated data, and then if we found everything is okay, then only after some time we delete that copy, or we just keep it as it is. So in future, if we think like something went wrong, that time we can go and see like what was the data in that time, right? So with Snowflake, you no need to create any copy of your table. You can just directly go and do your changes in your tables with the data. And for 90 days with enterprise edition, if the time travel is set to 90 days, then you can go and see the data up to 90 days in the same table without making any separate copy on the database, because Snowflake itself create copy. So suppose or let me ask you this question, do you have any knowledge, any one of you, on the S3? S3 is the storage, right? Here if we talk about AWS, like has anyone used S3 bucket?
No, we are aware about S3, but not used.
I use Anupam.
Right. So if you are aware of S3, there is a feature of versioning, right? In the S3 bucket, you can upload any document, and if you set the versioning enable as an option, that means you will keep the history of all those files. Like if you are making any change in that file, it will be stored as a version in the S3 bucket. The same thing is happening here in the Snowflake. So it is maintaining the history, like at that point of time, this was the table, in the sense the storage, and it keeps track of all the history in the S3 versioning. So whenever you go back in time, it is just retrieve back that version of the file from the S3 location only. Okay, so just correlate like how it is working, the time travel or the cloning we are going to discuss in few minutes. Okay, before that, there is like two main important thing in Snowflake, like one is compute and another is storage. And out of these two also, the compute is very much important. Okay, so compute is called as a warehouse in Snowflake. So in this front end screen, so if you are like new to Snowflake, right, you may see a different screen. Okay, let me take you to that screen. So you are able to see this screen, right, where I am logging in.
Yes.
Yeah. So if you are new to Snowflake, right, whenever you create a new account, you will see this kind of window, or this kind of a screen. There is, you can see this classic console as well here. Okay, so I will explain first classic console, then we can come to this new console as well. This is called Snowsight. Okay, so if you are seeing this window, right, here it is Snowsight, just click on this, it will take you to the new interface, whereas this is the classic interface, which is like the old one. Okay, here if you see, we have databases, we have share, we have data marketplace, warehouse, then worksheet, history and account. Okay, so database, where you can see all your databases, and here also you can see your databases. Second is sharing, when we do the data sharing, that is also one of the feature of Snowflake. Data marketplace means nowadays like data is new oil, right, we say. So companies are sharing the data and they are earning money from that as well. So this is a marketplace where you can see the data from different providers. So suppose you want to get like suppose last 50 years of that weather data, you can get it from here. Okay, the warehouse is the compute power, and we can configure it for our query execution. So we are going to see more in detail just now. This is the worksheet. When you click here, it will come here. So these are the tab you can create, like multiple tabs you can create a new worksheet. Okay, and you can work on it, and you can have multiple worksheets, and once it is like multiple, then you can see in the drop down as well here. The next window is the next tab is like the history, where you can see which all queries you have executed in the past, and I think it will keep store up to 14 days of history by default. Okay, this is the account tab, where you can manage the account related options. So generally you won't have access to this if you are as a developer. You will have access to this if you are kind of sysadmin. Not sysadmin, only the account admin will have this kind of access. Okay, so this part is also governed by this role. Okay, so in Snowflake or any other database, right, here it is everything governed by the role only. So the default role is the account admin. That means it is having the highest role. So we will go on the role side later, but whatever you are seeing here, it is depend on the role. So let me just check, change the role as a public. Okay, in public role you will see that account tab will be disappear from there. Okay, you can see, right, this account is not available because the public role does not have access to the account tab here. So they are not entitled to perform any account admin task over. So now let me go back to the account admin. That is the highest privileges, but we won't get it most of the time for our normal development work. We will have most of the time with one of the database or few of the database as a edit access, where you can create table, you can load the data, you can drop the table, and so on. Okay, so now first come to the warehouse. Last time we discussed a little bit on this. So this warehouse is the compute power or the compute engine for the Snowflake. Let me just see what all options are here when you are going to create a new warehouse. So first you need to give the name. You can give name anything. Now this is the size. Size means the computation power your warehouse will have. So extra small will have the smallest compute power available. The small one is just double the extra small. The medium one is just double the small, and the 4 times the extra small. So this is how it is like the compute power is increasing just by 2 whenever you are selecting the above warehouse. So your compute power is just double, whereas this feature is not available in BigQuery. I'm not sure about Redshift, and I think there it is also not available. Here you can go and choose if your query is very large, very complex. Suppose in current execution, if you are performing the execution the extra small, if it is taking like 15-20 minutes or maybe 1 hour, in extra small it can complete within 2-3 minutes. Okay, so see, it is not a thumb rule. If your query is running for 10 minutes in extra small, if you do small, it will be finished within 5 minutes. Okay, it is not a thumb rule. It may run for a faster. It depends on the query, how it is well articulated, and how the data is stored. Means data storage is not a concern, but how you have written your query and how much the data it is consuming from the table. So if you are having lot of tables are consuming, then the query is very much complex. Then increasing the warehouse is just one of the options to tune your query, right? In Oracle, if you see the options, the hints available, parallel hints and other hints. In Snowflake we do not have any kind of hint. So either you tune your query. For the best practices we can use, so we will discuss those as well, or second thing, you can hit and trial to increase the warehouse size. Okay, now the question is like, you can see here it is 1 credit per hour, 2 credits per hour, 4 credits per hour. So as I mentioned previously, in Snowflake the computing build as a per minute. Okay, not per minute, it is per second basically. Okay, let me give you one idea as well on that. Before that, what is credit? Credit is like it's a small unit which is consumed by the Snowflake to provide the compute power. So this credit is of some value. Okay, what it mean, with different reason, as you, if you are aware of cloud provider, right, in different reason they charge different for the compute power and the storage power. Storage is like the global service, so there you will have the same kind of same price available everywhere. But for the compute power, you will see price difference between the region and the cloud provider. So the one credit is worth change based on the cloud provider and the region. And also as of now it is like I think $4 per credit. So that means if you are running one extra small warehouse for 1 hour, it will cost 1 credit. That means ultimately it will cost you $4. Okay, so $4 for 1 hour in this one. If you are running your small warehouse for 1 hour, it will cost you $8 or 2 credits. In a similar way, the other warehouse will cost you the same. Okay, so whenever you run your query, right, so try to run first in the smallest warehouse and see how it is performing. So first see your query, like how complex it is, how means how much data it can read on the tables, and all the underlying tables are having how much worth of data. Okay, so that one thing you should know before running your query, so that you will have better idea to whether you should start with the extra small, or from the start you can go with the some other databases also. Okay, now comes the multi-cluster of concept of multi-cluster. Okay, multi-cluster means the same power of the cluster of same power can be replicated multiple times. Okay, so let me give you the analogy from the cloud side. In AWS we have the auto scaling, correct? In auto scaling, what happened, whenever there is more traffic or more CPU usage for that particular machine, particular EC2, if you have enabled the auto scaling, it can spoon up the same configuration of machine, another machine, and up to your configuration, like how many machines you have configured to run at a same time. Suppose you have configured 5 machines, so it can based on the load, it can go up to 5 machines, and whenever there is a less load, it can reduce up to 1 machine only. 1 machine in the sense whatever the minimum configuration you have choose. Okay, so in the same way here it is minimum cluster is 1 and maximum cluster is 2. What it mean, it will start with minimum 1 only, and we can choose like till up to how many cluster it can go based on the load of the load on this extra small warehouse. Okay, so suppose you just started with this, if you keep 1 and 1, right, if you keep this maximum cluster as 1 and 1, it is not showing the minimum one. Why? Because in this case maximum and minimum are both 1, you cannot go beyond 1, so that's why it is not giving you the another option. If you select 2, that time you have minimum cluster, like how many so how many cluster you can run at a time. Okay, so you are getting this point. The multi-cluster is provide the help whenever multiple users are consuming the query. As I mentioned previously, when like 50-60 users were consuming the data from Oracle, the query may go downgrade whatever it is running on the system. Whereas if we configure this setting properly, so if we know at a certain point in time there can be like hundreds of user can use the same data warehouse and query some tables, we can set it accordingly. Suppose like I can set it to up to maximum 5, but it will start with only 1 only. Okay, any question here? It's a very much important concept with respect to Snowflake. Is it clear?
So after the load is decreasing, right? So the Snowflake will automatically decrease the cluster
Yes,
to,
yes,
to back to 1.
yes. So that is called the scaling policy. Means it is the clusters are automatically auto scale. It can upscale and it is scale out and scale in. Okay, there is like two concept, right? Scale in and uh, scale out and scale up and scale down. Can anyone tell me the difference between these two? Scale in, scale out, scale up and scale down. Anyone, any idea?
Scale up and scale down may be related to vertical scaling,
Correct,
and scale in and scale out means adding nodes and
correct,
decreasing nodes.
correct, absolutely true. So the scale up and scale down means the increasing or decreasing the size of the warehouse, whereas scaling in and scaling out is the number of clusters is like scaling out, like the same number of the same cluster is just replicating in itself. Okay, so there is a concept of auto scaling, right? In only one of them that auto scaling is applied. Okay, as I mentioned, this is applicable in the scale in and scale out only. Means you set the minimum cluster as 1 and maximum cluster as 5. Whenever the loads get increases, it will increase the number of cluster as 1, 2, 3, 4 up to 5, and when the load reduces, it will slowly remove the clusters, then it will come to 4, 3, 2, 1. Okay, whereas scale up and scale down, right? If you are running your query in extra small warehouse, it won't automatically convert into the small or medium or anything. You need to change this size of warehouse manually before running your query. If you think my query is running and if I just alter my this warehouse to another one, it will happen, but your query in which warehouse it already started execution, it will be running in the same only until unless you killed it and resubmit it again. Okay, so this scale in and scale out is automatic, whereas scale up and scale down you need to do it manually. Okay, now
So Anupam, we are sorry to interrupt.
Yeah.
So if we are running a query, the query is in process, and we have changed our size from extra small to large. Will the processing increase, or we have to abort the query and then again use the warehouse?
Yes, so as I mentioned, if your query is started on any of the cluster, it will be remaining in that only. Even though if you just execute the alter warehouse command, right, it will alter the warehouse for that it will alter the size of that warehouse, but your query which is already started in which cluster size, right, it will remain in the same until you kill that and resubmit it. So if your query is running in extra small and you think it is taking like 15-20 minutes, and you just think if I can just increase the warehouse size and it may finish quickly, right, it won't happen. Just think from the underlying EC2 machine or any machine. Suppose EC2 machine or the extra small is what, let me just open a new tab. Okay, just a minute. Let me share my screen. Okay, so I'm searching the EC2 instance type here, right? EC2 instance type is means the size of your machine. Okay, so underlying these machines will only be running in our Snowflake, correct? So if I pick this type of machine, there are like n number of configurations available for the EC2 machines or the server, we can say. So suppose this machine is like it is M5 large, right? It is having 8 GB of memory and it is having two virtual CPUs, correct? So suppose, so underlying warehouse, we will have this kind of machine only. Okay, when you select the extra small, it may have this one on or any other one. When you select any other warehouse, suppose this is like this is extra small and this may be the 4XL, just for giving a simple example. Okay, the difference between these machine is the CPU and the memory. Here you can see it is like 128 GB of memory, whereas it is in this one we have only 8 GB of memory. Okay, so suppose if any of the job is running in this machine, it won't transfer automatically to the another machine. You need to kill that query and resubmit it again so that it can go to the new machine. Okay, if in future Snowflake will provide this kind of feature, then also whatever the computation has done, because whatever the query you are running, right, the computation power will be used for this machine, right, and it is keeping the computation stored in its own CPU and the RAM only, right? But if you are changing the machine, that data won't transfer, right? It is not that simple, correct? So if you are running your query in a small one and if you try to execute a big one, your query won't be transferred automatically. You need to kill and resubmit it again, then only you will be able to see the changes, otherwise you won't.
So you mean to say that at one time my small warehouse and the large warehouse are running parallelly, right? If the query I have not bought, right? Hello?
Yeah. So it can run. If you are perform any alter command, right? Alter command on the warehouse, until unless you will run that warehouse, it will only be in your metadata only. Okay. Yes, theoretically it is possible. Like one query is running already in the small one, you can increase it, I think, but I need to check it. I haven't done that. Am I audible? Okay.
Hey, I have one question, right? I have a complex query, right, which is taking very long time, right? So what is the step to make the twin, right? Because somebody has written that code, they are asking to twin it, right? Because they are feeling it's a very slow, right?
Right. So first of all,
what is the approach we need to check?
Yes. I will tell you. So we have 10 minutes, right? So I think I have sent another invite, right? Or not? Can anyone, so how many people are there? Let me just write the name. Okay, so that I will send the invite again, or if you can just let me see, because I'll send one more invite. Let me send it right away. Okay, I will send it to you only. Can you guys ping me your email ID, please? Like I need to take it from somewhere, like I need to filter out. Can you type the email ID in the same window? So I will send another invite, otherwise like this meeting will be ended in 10 minutes. Am I audible?
Yes, Anupam.
Okay. Okay, I have received Akshay. Vivek, can you ping your email ID?
I'm not getting the option. It's a Vivek MCM at the Gmail. Vivek
Okay, got it.
MCM at the Gmail.
Got it. And who else we have? I got Manish, Sumit, and Akshay, and now Vivek. Shraddha, can you ping?
I'm also not getting option to type.
Okay, what is your ID?
It's Shraddha 658 Malaya at the Gmail.
Okay, got it. Who else we have? NS Satish. Satish, have you ping? Or let me search. NS. Okay.
Yeah.
Okay, I got it. NS Satish. So it will be 8:30 to 9:30. Cancel. Join with Google Meet. Okay. Snowflake. 8 to 9. It's will be 1 more. Yeah. Can you check your email whether you have received the invite or not?
Yes, got it.
Okay. Yeah, if all of you have received it, right, so we can I think we have 5 more minutes in this one, then we will if it is dropped, right, then we can move to the other one. Okay. Yeah. Okay, so Vivek, to your point, right, to tuning, right, first we should understand like how Snowflake is storing the data. It is storing the data in a columnar format. Columnar format means if it is like columnar format is giving the faster performance when you are retrieving the query, and if you are giving the particular columns in the query. Okay, so first thing, not to use star in your query. Okay, why? Because if you give a star, right, it need to select all the columns from that underlying table, whereas after joining all these tables and all, in last you may be selecting only 4 or 5 columns. Okay, so for query performance, first thing is you should select only the selected column. That is very much important. Second part is I think that is well known to all of us, like the limit the data. Okay, and the third thing, you can increase the warehouse size as well. Okay, so to increase the warehouse size means if your, so suppose one of your query, Vivek, like if it is running every day, if you move into production, right, and this job is like every day running, and if this job run every day 30 minutes or 1 hour, you can reduce the time by increasing the size of that warehouse. Okay, and you can change the size of your warehouse dynamically as well to execute your that query only. You can do that. Means how you can do that? Before executing your query, you can run the alter warehouse command to increase the warehouse size, and once your query is done, you can reduce the size of the warehouse as well. Okay, or maybe you can create a separate dedicated warehouse which will be only running for your query, and it will not be available to any other person's use. Okay, that is these 3 things you can do in that.
So basically what happened, right, what the data scientist is asking, right, so whatever the data they are getting from that query, right, so in 1 minute they are getting some 10k records, right.
Okay,
so it's they want more record. The 10k record should be coming within a less than a minute, right.
So how complex is the query?
Sorry,
how complex is the query?
They are joining some 4 or 5 tables and all that, right.
Okay.
Because it is written by some other developer, right. So as a Snowflake developer, I need to tune that query. How more we can tune it, right.
Okay, so for that, yeah, so for that, what other option you can do, if you are able to see my screen, just go to your query, right, on the history tab you can see your query execution. There you can just click on the query ID and you can do profile here. Okay, details, and come to profile. In profile you will see here it is showing as more.
Are you sharing? I am getting only that.
Okay.
AWS.
Oh, sorry. Now I'm sharing.
Okay.
Okay, so go to history and then select your query, the query ID,
Yes.
and then you can see like how your query is
Query
executing.
is taking time.
Yeah, so here you can see, so this is simple insert query, right? So let me select any select query where I have selected or read the data yeah, it is 48 GB, right?
Actually,
Mm-hmm.
actually, this is written by some other developer and some other project, right? So they pull me in some other project, right, and asking to twin it because they want to move the code to the production before moving to the product
Correct.
code to the production, right? They want to make sure that right everything will be fine.
Yes, yes, yes. So
Okay, yeah.
so first you can select only the columns which are required, correct? And also you can see in the profile where it is taking more time, right? So you can see in this one 2 of 3 nodes. So most expensive node it is showing as 2 nodes are most expensive out of 3, right? And you can see this result and this table scan. So basically here the table scan is the most expensive node here, right? Because the query is taking
Suppose table scan is taking time, right? So what is the step we need to follow?
so
This is
just
the
try to,
scenario.
yeah, so there you just try to limit the data first. So see, table scan means if you have like 10 GB or 100 TB of data, for example, and from there you are selecting, correct? Put the filter if you can do that, like limit your data. Otherwise if it is,
Okay.
if it is going for the entire table scan now, it will be a little bit slow, means not very much slow, but see, you can see the difference, right? If you need to pick out of 2 3
Yes, yes.
buckets, whereas you need to pick from the 100 buckets, correct? So just limit your data first, limit your data. Also you can keep only those columns which are required in your final output or in your joining conditions. Just see like the joining conditions are proper or not, or whether they are like kind of very much expensive, right? And also you can come here and see like how much like this will give you help, like from this table how many data you are pulling also, right? Sometimes we put some different joins and that may come into some Cartesian product, means I know it is the query is running, but I'm just giving some thoughts over here. So you can see
Correct.
the rows also from this step to this step. Okay, it is stopped. Hello Manish.
So basically the SQL optimization techniques are there actually, for initial.
Yes.
So only those columns which need to be consumed should be selected.
Yes.
Filter, then filter conditions, and and mostly numeric conditions are better
Yes. Yes. Yes.
on those things.
So
Yeah.
whatever the SQL query tuning or the optimization techniques we have, right? We can apply the same here as well. Along with this, along with this, uh, just the last option, to increase the warehouse size. Okay, and I think
What about the clustering, right? Suppose in the filter, whatever the filter, suppose we have taken the country as a filter criteria, right? And the country value will be scattered in many multi-partitions, right? So in that case, the clustering we can go that, right? Alter and cluster that keys, right?
see,
Where condition.
clustering is, I think, advisable if you have some TB of data. Let me check the Snowflake documents.
Okay.
Even
Yeah, more than
Snowflake does not suggest that like from the starting, but if you have like TBs of data, okay, then only they suggest to do that, because the clustering means, right, the movement of data, correct? So that will also cost you, means it will cost you, right? The clustering is not free, because you are moving the data from one storage to another storage. And I have read somewhere like if you have tables of 1 or 2 GB, it is not advisable to have it. It is like some
Yes, yes.
100,
Yes, I read it. Yeah.
100 GB or something.
Yeah,
Then
got it.
only we should go with the clustering key. Otherwise your cost will be too much. Okay.
Okay.
Yeah.
So one more question, right? Suppose I am running the query, right, on the small warehouse, right? So the result of whatever the query has not given the output, and after that I alter the warehouse and make it to the extra large, right? So in that case, result cache will become, or I have to flush out the result cache?
Okay, so see, result cache is based on the warehouse only. Okay, warehouse in the sense, you can think the virtual machine, correct? If you are changing the virtual machine, then your cache will not be there. It is storing in that particular machine only. Okay, so cache, if you are
Okay, got it.
it is related to the warehouse only. If you are changing the warehouse configuration, then your cache will be lost. Okay, and if you have not completed your statement, right, then cache won't build. So if you want to have cache available and you just want to reuse it, like not to change the warehouse. Okay, let me change the size of warehouse. Okay, so let me present my screen again, and we will do this exercise right now. Okay, so to answer your question whether, okay, are you guys able to see my screen?
Yes.
Okay.
Yes.
Okay, so in worksheet let's take the biggest table we have, right? In Snowflake sample data, let's go with the TB of data. This is 10 GB, 159 GB, right? So just right click and place name in the SQL. Okay, so let's start from this. Let me do like limit 5 just to check which all columns are there. Okay, so this warehouse is currently is like extra large, right? We can pick the, I think, line number. Okay, sorry. So I'm just trying to put some, okay, this returning flag we have, right? So I'm just trying to put some where conditions so that it will take some time. Where line returning flag equal to A. Okay, now I'm removing this. Okay, and let first run this query on the extra small warehouse. Okay, and we will see whether it is allowing us to change or not. So I'm running it. Now go to the warehouse. It is showing as running, right? This is our extra small. Click. Okay, and then configure, right? We need to increase like small and finish. Okay, here it is finished. Okay, I think our query, yeah, is still running, correct? But to your question, as I mentioned, here it can, we can see it is changed the warehouse size. But if we go to the history, right, let me refresh it. Here it is still running in the extra small. So that is what I was mentioning. Even though you can change the warehouse size, it will be allowing you. And suppose if I create a new tab, right, and again pull some data, place in the SQL.
So Anupam, different warehouses having different cache, right?
Yes.
So it's kind of a different machine we are running the query, right?
Correct. So we can see in the history, right, our previous query is running and we have executed the new query. Now let's see. Let me refresh. Yeah, so you can see the another query we have executed, it is running in the small one, whereas the old query is still running in the extra small, right? So even though the name is same and you have configured it, but it won't change automatically from one warehouse, means the one configuration of warehouse to another configuration. Cache, your question on cache, right? So I think if we change the configuration of warehouse, right? I think then also it will keep the history. I think the cache it will keep.
Because somewhere I read that, right, we need to do this. Suppose we are doing the scenario, right? So that scenario we need to flesh it out first, then only. Otherwise, we will not see the difference actually.
So flesh it out means if you are executing the same query again, right? If you are executing the same query and if you want to see whether it is pulling the data, means, and you want to make sure it is going to hit the database or the storage and bring the data, that times we need to flush that cache. Okay.
In our case, we didn't get the data.
But
itself, right?
one
So
thing is there
nothing will be in the result cache, right?
Yeah. One thing is the cache will be available for 24 hours, I think. Okay, you can do more study on that, but I think as of now maybe it is available for 24 hours only, and with the particular warehouse. But I'm not very sure whether if you are changing the size of warehouse, whether it is available or not. But if you are going with one warehouse to another warehouse, the name is different, then for sure you won't be able to use the cache, that is for sure. But with the same warehouse, if you just configure or change your warehouse size, then I think you can use it. Means I'm not very sure, I need to also check on this, so I'm not.
Okay, I will check that, no problem. I will check that, no problem.
Because see, for the cache also there is a different service in AWS, and I think Snowflake is also using that service. So maybe with the warehouse name it is keeping the result in that cache, right? So with the warehouse name it may be possible, but if you are changing the warehouse, then it may not be possible, I think so. So I will check on that as well. Okay, so you can see this queries. Okay, this is finished. Okay, let me refresh it. I think both the queries, okay, one is still running, which is running on extra small, because this is like 159 GB something, right? So that is why it is still taking time. So the point is clear here. If one query is running in any of the virtual warehouse, if you, even though you change the configuration of that warehouse and execute another query, the new query will be running on the new configuration, but the old query will still be running on the same warehouse, on the same configuration size. Okay, so now, yeah, any question?
Here the billing is per minute or per second?
Yes, we will come to it. So billing is basically per second here. Okay, billing is per second, but the minimum time when any warehouse started, right, that takes 60 minutes. So when a new warehouse started and you executed your query and you run a simple query and just and you haven't run any other query, right? So if you see this option, right, let me just go again. If you see this auto suspend option here, that means in how much time you want this warehouse to be auto suspend. Okay, auto suspend means you are just stopping your warehouse. In the same, in AWS you have EC2 machine, and when that EC2 machine is not in use, you can just suspend it, so you won't be charged for the compute power. Otherwise, if your machine is up and running, and if even though you are not executing anything or not performing anything, it will be going to charge you. Okay, so the minimum configuration you can do auto suspend as a 1 minute, but it is not available in this one. How you can do that? You can click on source SQL, sorry, name you need to give. You can do show SQL, and here the auto suspend configuration is 600. You can make it as 60, and then you can change it. Means just copy this, and from your worksheet you can run it. Okay, we missed one thing, the warehouse type, right? Let me go back again here. That is also very much important, the scaling policy. Okay, the scaling policy is standard and economy. So now the question is, if you are running your query, which scaling policy you should use, the standard one or the economy one? Standard one means whenever you are running any query on the database, suppose you are running 10-15 queries and it is running, okay, and your warehouse cannot take any more queries. Okay, what it mean? If you do not have enabled this this multi-cluster configuration, right? Then if you have only one cluster, if you executed 10 query, it is running fine, but when you executed the 9 query, it will be in the queue. Okay, because your cluster is minimum only, right? One cluster. But if you have set some value over here, how it will scale? That means if you put standard, right, as soon as the 9th query will hit, it will automatically create a new cluster. The number of active cluster will be 2, and it will start running your query. The next queue query will start running in the cluster 2. Okay, but in the economy but in the economy, what will happen? First, your warehouse will determine whether if you spin up a new cluster, whether it will have sufficient amount to be to have it running for a 6 minute at least. What it mean? Suppose you were running 8 queries and you just submitted 9th query, and that 9th query, if our Snowflake determine like it will be finished in within 1 minute, it won't spin up a new cluster in the economy mode. It will be keep in the queuing until it has sufficient amount of queries, like 7-8 queries. Once we have 7-8 queries, and our warehouse will determine like at least it will run for 5-6 minutes, then only it will spin up a new cluster and it will execute your queries on that new cluster. So to save the credits, you can go with the economy or you do not want you want minimum queuing for your query, then you should go with the standard policy. Is this point clear?
Yes, so it will queue up the query if we choose economy mode.
Yes, if you put economy, it will keep in the queue, and but if it gets like, or if it determine the next query will be running at least for 4-5 minutes, then it will push that query, or it will spin up a new cluster and it will throw it will execute the query in that cluster. Okay. Yeah. So we discussed already this auto suspended time, right? So auto suspend is like after how much time your cluster will automatically shut down, and we discussed like we can make it as 1 minute. Okay, so now your question, Asha, you're charging for the warehouse for how much time, right? When you start any cluster, it will charge for minimum 1 minute. That means minimum 60 seconds. Okay, but if your cluster run for 65 seconds, it will charge for 65 seconds only. It will not charge for you 2 minutes. Okay. Whenever you start a cluster, it will charge for minimum 1 minute, and further it will go for per second only. So we can say minimum will be 60-second billing, and further like to how much time it was running, that only. So
Okay, whenever the cluster got suspended and we trigger any query, so by default it will take a billing of 1 minute,
yes,
right?
yes,
Suppose that
correct,
query finishes within 30 seconds or
correct.
15 seconds.
Even if 1 second, it will be you will be charged for 60 seconds.
Okay.
So in this warehouse, on this topic of warehouse, you will see at least 5 questions minimum, or maybe 10 questions on this warehouse in your certification if you are going for. Okay, so you just need to know all these things, which is like auto scaling, scale in, scale out, and the concept we have learned, right? If your query is running in one cluster, they will give you the same scenario, the same which Vivek has asked, the same question they can put into your paper. And most of the questions, they will be like true or false, or the simple question, or they will give you some scenario based question like this. If your query is running in a one warehouse, a small warehouse for 15 minutes, and you think you can increase the warehouse size, and you can your query will be execute faster, whether it is true or false, they can ask you, or they can give you some other option also. So there will be, I think, five questions minimum from this topic, warehouse. So make it very clear. Okay, and I hope, like, how to create the warehouse, it is pretty much simple. You can just put the details which is here. If you want to change this auto suspend, just click on you just name it, click on source equal, and just copy this query, execute this on the your worksheet, and your warehouse will be created. So we can do that here as well. So you can create any number of warehouse, there is no problem. And you won't be charged if you are just creating the warehouse, because this create warehouse statement is only the metadata statement. It is not going to create any physical server until unless you are going to run it. It will be only running when you are going to execute it. Okay, so what is the scaling? Okay, so it is in running because it is having 10 minutes as a. So what you can do, you can click on suspend as well directly from here, or you can execute the query as well to suspend it, the alter warehouse query. Okay, so now there is another option, right? Or let me just give you this. Okay, so suppose there is one okay, suppose you have very large query, right? And if with using your ETL tool or something, you are running the query, and you have very complex query, and that query, if you are running in small warehouse, it is taking like 1 hour, but if you are running that in 4XL, it is finishing in 5 minutes. Okay, how you will handle your scenario in your day-to-day execution? Can anyone explain? Any thoughts?
Sorry, Anupam, can you please repeat the question?
Yes. So suppose you have very complex query. Okay, if you are running that query in extra small warehouse, it means your default warehouse to run your job is the extra small only. Okay, your all other jobs, like your thousands of jobs, are running on extra small, and they are finishing in within like 1 or 2 minutes, but you have only one this one query or one job which is taking like 1 hour to finish on the extra small. But if you change the warehouse size to 4XL, it will be finished in 5 minutes. So how you will execute your this job on which warehouse, or what you can do to finish the job as soon as possible.
Okay, so as you mentioned earlier, so we can configure warehouse something like for particular job, we can use a particular warehouse, and like there are small queries which are finishing within a few minutes, so we can allocate extra small warehouse to them, and the 1 hour query we can give some bigger size of warehouse. So if we can configure like that.
Any other option?
Performance tuning.
No, only from the warehouse side. Any other option you can try?
Economy means standard and economy.
That is only scale in that is the auto scaling policy. But as I mentioned, like here, what you need to do, you need to change your warehouse size, right? What all things you can do. So one option is like you can create a separate warehouse where you can give where you can give altogether a separate warehouse with the particular configuration that like every time it will be going to use that. Or the second option you can do, before running your actual job, right, or the actual query, you can execute this command: alter warehouse, the name of the warehouse, set the warehouse size as medium or XL, right? We were discussing as 4x large. Okay, that you can do. So just alter the warehouse before running your job, and after execution of your job, so here you can run job and then alter the warehouse, and you can do it as a small only. Okay, you can have it, right? Suppose Informatica jobs, we have the options of pre SQL and post SQL, right? Something similar anywhere, right? If you are creating a procedure to load the data, means to transform the data, so in the starting of your procedure you can have this kind of scenarios as well, right? Whereas like you do not want to create multiple warehouse, like this is one warehouse is dedicated for your ETL, you can do anything, but no one will, means admin will not provide you any other warehouse. In that scenario you can do this. Then the user which by which you are running your job should have the change permission on the warehouse, so that you can increase or decrease the size of your warehouse. So this is like scale
Anupam,
up. Yeah.
Do the developer have this authority to change the warehouse even if we are using it in procedures?
See, procedure, if you're running the procedure, right, it depends by which user that procedure is getting triggered. If you are executing the procedure manually, so it is depends on your account permission or your user, the current role which is using, right? It is not on the user, it is based on the role basically. So one user can have multiple roles. Okay, so depend on the role, and that role has the permissions, you can have it, means it is configurable, right? But in production generally we execute the query using the role which have like kind of edit access as well on the database, and can upscale or downscale the warehouse as well. So that particular user can scale up the warehouse and scale down the warehouse as well.
Okay.
Yeah. Okay, so this part is clear. Any question on this warehouse in this topic of warehouse, because it is like very much important, and I would suggest you should also go through the documentation of this, like how you can create it, how you can change the configuration, right? And you can also play with the running query and changing the warehouse size and all. So we have not tested that minimum and maximum clusters, right? Like you have not seen, but when you are running the query, right, it is showing as minimum and maximum 1, minimum maximum is 1, and you can see how much query is running currently. Okay, so you can see this query is still running in the this warehouse, and it is like it is not okay, it is in the suspending condition. So I think it is shutting down this warehouse. So you can see how many queries are running here, how many queries are in this queued, and yeah, like who's the owner of this. So that all detail information you can see here. So the main thing to change your configuration of your warehouse is to check this queued, right? If there are multiple queries are queued here, then you need to apply the auto clustering. That means you need to increase the number of clusters for your query, so that the queries which are going into queue, it can move to the new cluster, and this can have automatically. Okay, so you can check this queued for your queries, how much queries are there as a queuing. So yeah, on the warehouse side it is done. Let me give you a little bit idea on the storage side as well. Okay, so we will be covering it in a briefly. Okay, so storage is a micro partition. Okay, so micro partition is a 50 to 500 MB of small chunk of data which is stored in a cloud storage layer. Okay, so the logical structure is like, you will see table like this, whereas in physical structure it is like one micro partition contains the data, and that data is in columnar format. Columnar format means one column worth of data will be stored together. So here the type and these are the values, they are stored all together, one column all together at one place. Okay, the name column is stored here, country is stored here. In the same way, this type column is spread into multiple columns, sorry, multiple micro partitions. Okay, so
Sorry, Anupam, your screen.
Oh, sorry. Okay, you are able to see this screen now?
Yes.
Yeah, sorry. So this is a logical structure of a table, okay, where the data is stored as like type, name, country and date. Okay, this is a row. Wherever we see the data, it represent in a row manner, correct? But how it is stored on the Snowflake in a micro partition, it is stored as a columnar format. That means one column data will store at a nearest location. Okay, another type of column will be stored as a nearest. So instead of storing one row of data at nearby, it is keeping the column at a one place. Why it is? Because whenever we execute any query, right, we mostly select the column only, particular columns. We do not select the entire row of data, right? We only select the main columns which we require for our output, right? So that's why this columnar format is stored in such a way. This micro partition, like how this increase the performance, this micro partition will contain some metadata as well. This metadata will tell for the type column what is the minimum value and what is the maximum value. Okay, so if your query is running like where type equal to 2, correct, or type equal to suppose 5. So suppose your query is type equal to 5, the column, the type, if it checks the minimum and maximum value of this type column in this micro partition, it will come as 2 and 4, right? 5 is not in this part, right? So it will skip this micro partition. Now it will come here. It is having that 5, yes, then it will read the data from here. Then it will check the metadata of this, whether this type column is having minimum or maximum value. So in this way, it is eliminating the micro partitions to read, and this increase the or speed up the query execution time. because whenever we put any filter also, right, we keep on the column level, and this metadata, each micro partition contains metadata about all these columns. So the minimum and maximum only just one thing which is stored as a part of metadata. There are like other different things as well. Okay, so this is about this micro partitions. Now we have discussed about the execution part, we have discussed about the storage part. Now we will come like how we can work on the Snowflake tables. Okay, so let me come back again to our Snowflake. So in the database, right, in database what you can do, you can create a database, right? So this from now for some time it will be like similar to any other databases, right? You can create a database. Inside it, suppose I have created this database. Inside the database I can create tables, views, schema, stages. File format is a new thing, I will tell you how, means how we can create this file format. Then we have sequences, it is like any other sequences, and pipes also we have. So these are the objects. So from the certification perspective, you need to remember like in a database or schema which all types of objects can be stored. Okay, in a typical database we have tables and views or schema mostly, right, in the database here, or the sequences. Whereas in Snowflake we have stages as a new part, file format as a new part, and the pipes as a new part. Correct? So you need to remember it. Now Snowflake also support the semi-structured data. Okay, what it mean? Just give me 1 minute, let me put my headphones on. Okay, am I audible? Hello? Hello? Okay, so inside the database you can have this kind of, right, and Snowflake can store the semi-structured data. So that's why we need to define this file format. So if you have worked on Hive, right, while reading or storing the data into Hive tables, you need to define the file formats, correct? Because in Hive we were storing the data into different formats. So we have Parquet, we have CSV, and other Avro, correct? So different formats. Yes, so here also we can store the same, right, because it is like on top of the Hadoop or the Hive tables we have, right? So it also support most of the file formats. So let me show you which all file formats it supports. So it supports CSV, JSON, XML, Avro, ORC, and Parquet. So whatever you were seeing, if you were previously working with Hive, right, so it supports all of these file types, file format types. So you can read the data from these files into Snowflake directly. Okay, so for us, for a simplicity, I will select the CSV as for today, and we will see when we query the data from JSON in our future sessions also. Okay, so before that, like as a simple, I just created a simple table here, like employee ID, first name, last name, or let me go to some other database I created here. Okay, so I created one table as a first table here. Okay, how you can create, if you go to tables, okay, let me go back, click on create. So this is one wizard, right, where you can create the table, and if you have the create table statement, you can create from there also. Okay, so I'm just giving you one options through which you can create. And if you write all these things here, right, suppose I have added these names and all, if you click on show SQL, right, it will show the same statement which we can run directly also. So no need to go from this way, but I'm just giving you one example here. Okay, so in this table there is another feature to load the data, right? So from this feature we can directly load the data into any of the table. So to load the data we need to have one warehouse, because warehouse will do the computation, right, and it is going to read the data from file and load into our table. So first we need to choose our warehouse. Second is the source file, so we can go and select the source file. Okay, so we have selected here. Just make sure the file format which you are having, we also choose the same file format. Okay, so the file format here we have is a CSV file, right? So I am creating one new file format, CSV file. I am giving the file format from this drop down, I am choosing as a CSV, giving the file separated as a comma. So just make sure your CSV file is also comma separated, and I am just giving as a like read one line or header lines to skip as a one only, and trim spaces. You can go as a click here also, you can see click file format. So this option also you can use to create, or you can just click on finish here. Okay, so I have added this CSV file, and now you can click on load. So you may see this may fail multiple times. Okay, the main reason of the failure here is the type mismatch. Like you have selected as CSV and comma separated, right, whereas your file may be as a pipe delimiter. So first you need to know what type of file format you have, and the same exactly you should choose from the drop down list. Okay, so it is a simple one, CSV, so it is loaded without any issue. But also if you are having the date column, right, if you created date, so this way it gives us lot of issues if your file format is not proper or your file is not proper. So if you are pulling the date, right, dates, because I have faced this challenge multiple times. So like we no need to have this very often to load the data from file manually, right? There will be some jobs by which we are going to load the data. But if you are practicing it, right, for your own practice, if you are just creating a file format and loading the file, and if it is having the timestamp, right, so either you should choose a string one, or you should have proper comments in that, or you should define the proper format for that particular column, because I have also seen most of the time. So what I do generally, like I'm just doing for my practice, I just select as a varchar and it comes as a varchar only. So you may also get stuck multiple times to if you going with this wizard to load your files into the Snowflake table. Okay, now the important thing is the stage. Okay, anyone has any idea on this stage in Snowflake? What is the stage in Snowflake? Can anyone explain, please? Okay, let me explain. So just think of a real warehouse. Okay, if you have seen real warehouse, the warehouse is used to load some product in it, right, for the long to store the product for long time, correct? Outside your warehouse there is some platform, right, where your suppose trucks are coming, or your large vehicles or maybe trains are coming, something, right, that one of the platform there where you are keeping that product for a small amount of time, correct? Suppose you have wheat packets, right? So from your unloading the wheat from your truck, it will be stored for a little bit time there, and from there it will be go inside to the warehouse for your storage for a longer time, right? So this stage is just that part, that kind of platform where it supports the loading and unloading of data from your warehouse. Okay, it is on the same analogy. The stage is a place where you can keep or you can do unload or upload of your files in Snowflake. Okay, because our Snowflake is data warehouse, right? In data warehouse we are getting the data in terms of files. So here we are keeping the stage as a as a kind of temporary placeholder. Okay, so let me create one stage and show you. So stages are two type. Okay, one is Snowflake managed stage and another is external stage. External stage is related to the other external cloud provider. So S3 AWS we have S3, Azure we have this I think we call it as blob, and in the GCP we call it as cloud storage. So Snowflake manage, if you choose this one, it will not ask you anything. You just need to give the name and you can create it easily. Okay, but if you are choosing any external one, right, if you have used any external bucket, you need two things, the secret key and the access key, right? With corresponding to S3 I have used, it asks secret key and access key. If you go here, it will ask you the AWS key ID and the secret key. So this is the access key and this is the secret key. These are the two mandatory. Master key, if you have used any encryption, then you need the master key as well here. Similar way, Microsoft will also have this token and master key, and similar way this GCP will also have the same. Okay, it is not having, but okay, storage integration, because I have not used this GCP anytime, but in the URL only I think you need to provide it, because all the cloud provider have its security feature enabled, like no one can directly go and access any of the bucket. They should have some access mechanism available with that. Okay, so with AWS we have secret key and access key. So I have created this I have this bucket in my S3 location. Okay, and I have added this as a part of this. So I have the secret key and access key. So you can see it is use saved value. So you are not able to see this secret key, but I have already put into here. Okay, so why this external is required, right? So we are clear with the stage, why this stage is required. Stage is a temporary place where you store your data for loading and unloading. Loading means you are loading the data from somewhere to your table, and unloading means you are taking out the data from your Snowflake warehouse to some other place. Okay, if you unload the data onto stage, it can move or transport to any other place. Okay, so internal stage is Snowflake managed. Okay, that is not that controlled by Snowflake only. So you will not have control on the storage or the life cycle of the file. So if you are keeping anything on the internal stage, right, so internal stage is automatically set to clear its own place after some time. So in internal stage your files will be automatically deleted after some time, because Snowflake will manage till how much time the files will be there in the stage layer on the stage. Whereas if you want to keep your files for a long time, then you can use the external storage. That means external stage, that means on S3 bucket you can create one stage and your files will be there for long time, means it is external, right? So you have the power till what time you want to keep those files, and if you want to delete those files, it's up to you. Okay, so we choose most of the time as an external bucket because we have the power to keep our files safe for a longer time. And another thing, if we are going away with Snowflake, just for example I'm saying, okay, because most of the time there is one more thinking also, like today we have Snowflake, right, but tomorrow there is another product which is like 50% less expensive as compared to Snowflake, right? What will most company will do? They will switch to that platform, correct? And that time they also need to have the capability of their existing system. It can be moved very easily to the new platform, correct? So if your files are coming, if you are loading the data from files and all, they want to keep those files into some S3 bucket, so that in future whenever they need, they can directly copy that files from the external location to the another cloud provider. Okay, so that is also one of the consideration when you are choosing the external bucket. Okay, and for your security also, suppose if you want to keep with your encryption method, that also you can keep it there. Okay, so there are various options. So the main task of the stage to load and unload the files. So now as I have created, right, how we will use it, I will just explain you. So file formats we are already done, right? We can create any types of file format. These all the files which is file format which is supported. And sequences is the normal sequence we already know. Snowpipe is a new feature. Okay. Snowpipe is used to automate the data loading from the external files. Okay, Snowpipe, so it is a similar analogy like the pipe, right? What the pipe do? If you open the tap, the water will continuously coming out from that tap, correct? So in the similar way, the Snowpipe, we called it as Snowpipe, if we enable in our account, right, and to load the data, it has the capability, it can continuously load the data if any new files are coming at that place without any external scheduling tool or anything. Okay, we will see this S3 this Snowpipe also. So Snowpipe is to just the load data automatically. Okay, you just put your file into S3 bucket and that file will automatically load into your table. You can achieve it using the Snowpipe. Okay, let me come to the yeah, so we have created this bucket stage, right? I have mentioned here the stages. So I have created this first bucket. How we can access that bucket? Using the list command. Okay, so if you just do list @ first bucket, it will show what all the files are there, what is the size of those files, the MD5 functions and the last modified. Okay, so this way if you have n number of files, you can keep it here. Okay, and from that stage you can directly load into your first you can load into your table, and if you want to do automate that loading, you can use the Snowpipe. Okay, but we will come to this part little bit later. Before that, we should know what all the types of tables we have. Okay, so let me come here. Okay, yeah, so we have seen it already, right? So but we should know first the table type. So what type of table Snowflake has, and what are the different features. So Snowflake support 3 types of table format, or the different type of table. One is permanent, one is temporary, and one is transient. Okay, can anyone tell me about the permanent? Right. Okay, any other feature with respect to Snowflake which is available in permanent? Correct. So permanent table is those table like which have all the features, like what all the features we have with the Snowflake, right, with the tables. Correct. So the difference between these tables are the features only. Correct. So temporary and permanent we were also using previously in Teradata, right? You know Teradata. So in Teradata also we can create temporary tables. So temporary tables are like only for that particular session. Correct. If you just exit that session, your temporary tables will be wiped out. Correct. In this we have the transient table also. Anyone has any idea on this transient table? And another question, why you need to know what all types of table you have in Snowflake? Anyone give me the answer, why you need to know what type of tables you have? Correct, but why we need different types of table in Snowflake? Mm-hmm. So what is the difference between permanent, what is the difference between permanent and transient? Mm-hmm. Mm-hmm. Okay, correct, correct, correct. So the features you have mentioned, right? Fail safe, time travel, those comes with little bit cost, right? The cost of storage, correct? Because if you do if you enable time travel of 90 days, right, whatever the changes are happening in your table for the 90 days, Snowflake will need to store in the memory, means in the storage layer, whatever the changes you have made, correct? So for your storage cost consideration, right, you should consider the type of table you should create for your need. Okay, if any table which is not required, like you think like it is, this table is not that much complex, like uh, we do not need the fail safe feature in it, correct? So we can choose a different type of table, right? Some tables we do not need, suppose in our procedure, because in Snowflake we will perform most of the tasks using our procedures only. Okay, and in procedures we create multiple temporary table, in means temporary in the sense intermediate table. Okay, we do not want to lose those tables, even if the session is stopped, right? We need it for some time, but also we do not want to incur the storage cost, more storage cost. So in that time we can use the transient table. Okay, so your transient table will be in the memory for forever. Okay, until unless you will explicitly drop that table, it will be there, but the fail safe feature and the time travel feature will not be available in the extended manner. I think I'm not sure whether transient tables support 1 day worth of time travel or not, because time travel is maybe not available with transient, or it is just available for 1 day. Because I think with the transient there is no feature of time travel and this fail safe. So to reduce the cost, because failsafe will also charge some cost, right? After your time travel time has elapsed, it will keeping in the some cold storage or somewhere, so that so that Snowflake can retrieve the data back for you from that failsafe period, in that failsafe period. And the failsafe period is available only for the permanent tables. It is not used, it is not available for temporary and transient. Okay, so with this types of table, right, you may have question related to failsafe. Okay, failsafe, then time travel. Okay, so you need to be very clear on these three type of table, which type of like failsafe is supported by which type of tables, time travel is allowed by how many days with which type of tables. So you should be very clear on that part also. Okay, so we are stopping here today, and any question, like we will continue next time. So what all things are remaining, let me give you a little bit idea. So we will see little bit on the semi structured data, JSON data, how we can read directly in Snowflake. And then we will see the data sharing. Okay, what else? And anything? Yeah, Snowpipe, correct. Snowpipe. So Snowpipe, data sharing, right? These are will come in the our certification, and also the access part, right? The roles and all. So we will discuss these 3-4 things in our next session. Task and stream are not part of certification. Those are like very small, and means task is very small, stream is little bit if you want, we can cover in the last session. But from the certification, I think streams was not a part of the certification of core certification, but we will also explore that also. Okay, stream is used to keep track of the data chain in a particular in inbound data, and it can by using the stream we can have our SCD2 type implementation and all. But like that will take a entire one session to have that stream and all. So that maybe we'll keep it later, but next session we will go Snowpipe, then our semi structured data, and also data sharing and the access part. So we will finish it by next, and after that, if you want, then we can have it. Otherwise, like next Saturday we can finish it. Okay, or if you have any another scenario you want to discuss, we can discuss those as well. Yeah, sure. So that is a small thing. Okay, like you can go you can have auto suggestions available in the new. So suppose you are just typing some table name, right? It can auto suggest you in the new environment. So I will, yeah. So you are just type. Yes, it is a paid one. So certification is paid, means you can prepare and go to Snowflake site to register yourself and do that. So we can discuss more on the last session about the certification also. I think today's session it will be finished in I think 1 or 2 minutes. Okay, so thank you so much guys, thank you for your time, and have a good weekend. Yep, sure, thank you. Sure. Okay, bye.